This is the fifth in a series of videos where we're talking about an introduction to NetQoS and some of the capabilities of core components that are included in the NetQoS solution. So far we've talked about the Network Performance Center dashboard and how it can be an excellent place for troubleshooting application performance management issues, whether or not you're a CEO, a leader in IT, or whether or not you're just running a resolver group. Then next is we talked about the Network Performance Center dashboard, the NPC, and how easy it is to configure. We talked about some details around application delivery analysis and the benefits that can bring. And in the last video we talked about WAN acceleration and some use cases around that component. This we're going to talk about unified communications. And unified communications, the technology that CA provides through the NetQoS solution, will support Cisco, Unified Comms, Avaya, and Microsoft. And what we're looking at here in this example is we'll be looking at an Avaya voice solution. To start with regard to voice, if we're talking about unified comms, obviously we're looking at not just unified comms but what's happening on the shared network as well. And so ordinarily a solution will include needing to get information in the same dashboard what's happening on the network. So normally we'll be interested in also including not just the unified comms details but what's happening with the underlying infrastructure, whether we're talking about just the wide area network links, whether we're talking about IP SLA tests, whether or not we're talking about Cisco buffers, potentially including in this report WAN acceleration. All of this information we're likely to want to include in a voice over IP troubleshooting dashboard. And we can see here we've got some issues around particular thresholds being exceeded for our IP SLA tests, and I might want to drill into that detail to understand why that's actually performing badly. However, in this case, I'm just going to focus on unified comms and the information that we capture from the unified comms perspective. What we're looking at here in this portlet is we're looking at a particular install of Avaya, and we're also seeing some examples of Cisco and OCS in this same portlet. And we can see here on the Avaya system, we're seeing that there are 583 calls originating over the last 24-hour period, the time horizon we're looking at, and of this there were 25,000 call minutes. This is every transaction that we've managed to see across the network. And this is obviously not just polling the actual call manager, but potentially calling the handset, and depending on the technology, actually sniffing the network as well. One of the things I've seen through the field is the voice over IP installation might appear to be perfect and perfect MOS scores when we've actually installed the technology. But unfortunately there might have been issues with call setup times, for example. And we will only see that if we're actually seeing the TCP requests and the UDP requests from the handsets back to the call manager and seeing the response. I've seen in the field it taking as long as 90 seconds between when the handset is actually picked up and when the number's dialed and when there's actually a connection. Not exactly sure what you do for the 90 seconds waiting, but that was a real example. Anyway, we're going to look at this particular Avaya system and see why there might be issues. Now we're looking at a summary view, and through the summary view we're looking at MOS scores, and there's a degraded MOS score. We can also look at packet loss and latency as seen from the call manager and also from the handset and also potentially from network sniffing. We might want to have a look at the metric details. Or we might want to filter down before we actually do that. And we can see there's actually, the main issue is actually just in one site. Now I've chosen to name that site sensibly rather than leaving it at 192.168. or 10.10. whatever the network happens to be. And we can see here now we're looking at this particular call manager filtered by this network, and we can narrowed by call manager. We can see there there are some issues around packet loss and latency and excessive degree performance with MOS score. Now I might look at the metric detail, and we can see here because of the codec we're using, the MOS scores need to be above 4, we can see that over this period of time there was a degrading of the MOS scores. At the same time, there were packet loss as seen by the actual calls themselves, and there was an increase in call latency. We might choose to go into further detail and have a look at each individual call, I'll just bring up an example of a particular call record, having a look at the source, the destination, the MOS scores, back and forth, latency, etc., as seen by the actual call manager. In this case, I can conclude that actually it looks like the call manager's all right, so maybe there's an issue with the other things that are going across the network. And because the Network Performance Center has all of the information in one place at one time, we might want to compare sort of details around other applications that are running across the network. And we can see here that voice accounts for a certain percentage of normal applications, particularly during business hours. We can see, however, that source and destination for this particular network link, we can see at the time that the voice actually degraded, there was someone using lots of HTTP traffic, as seen by NetFlow statistics. And so we might drill into further details here and find out who was actually doing that and who actually broke our voice over IP install as a result of potentially doing non-productive activities on the network during business hours.